What if we build a resource bar together? One that reacts and comes to life with dynamic visual feedback, as it fills up, when it's full, or even when it drops. You will be able to use it as a mana bar, a progress bar, health or power, you name it. You will see, it's actually really simple. You only need two super easy to make sprites. Honestly, anyone can do it. Head over the free online photo editor Photopea. Click Start using Photopea and create a new 8x8 project. The canvas is tiny, so zoom in to see it better. Create a new layer and hide the default background. Select the pencil tool, pick the square brush, and set its size to 1 pixel. Choose white. This will allow us to change the asset color directly in the Unity editor later. And draw a frame like this. Then export the file as PNG to keep the transparency. To make the background, select the Paint Bucket tool and fill the inside of the shape. Export as PNG too. Open Unity and add a canvas to your scene. Find the canvas scaler component, change the scale mode to Scale with Screen Size, and set your preferred resolution. Create a resources folder, and drag and drop your two PNG files into it. To use them in your UI, select them and tweak a few import settings. Texture type to sprite, sprite mode single, pixel per unit 8, mesh type full rect, and pivot bottom. Uncheck Generate Physics, we don't need it. Then, under Advanced, set Wrap Mode Clamp, Filter Mode Point, Resize Algorithm Bilinear, Compression None, and hit Apply. We're going to use 9 slicing. This lets you slice a sprite into 9 parts so you can scale its center and sides without distorting the corners. Unity has a tool for this, but it isn't installed by default. If it's grayed out, just open the package manager and install the Tutti sprite package. Now, when you select your sprite, you will see an Open Sprite Editor button. Just move the green line to define the slice for both sprites. To work efficiently on UI, it's important to visualize the available area. Add a visual container by right-clicking your Canvas UI panel. Name it Helper. Toggle Unity's 2D view and change the helper color to a semi-transparent black. Alright, now that everything is set up, we can build the bars visual. This requires a bit of planning to build it correctly, but don't worry, I will explain all the logic so you can replicate it exactly or adapt it to your needs. I'm going to build a bar with a fake drop shadow for a sense of depth, progressive filling, a double fill bar, animation tied to the progression. Right-click your Canvas UI panel to create the main container, which we'll call PowerBar. Since our Canvas keeps the same proportion, change its anchor preset to middle center and set the container size to 128 by 1024. Now, whatever we add as a child of this container, we'll make sure it stays within these bounds. Let's start with the shadow. Right-click PowerBar, UI, Image, rename it Shadow, and drag and drop the background sprite into the source image slot. Then, Set the anchor preset to stretch and stretch, so the shadow scales with its parent. As you can see, the sprite didn't adjust immediately. That's because Unity tries to keep the element's original aspect ratio when you change anchors. Just set the margin to 0, so the element takes up all the available space. Remember, I said keep everything inside the frame. But if we set them all like this, they will just stack and hide each other. So let's apply a small 16 pixel margin to the left and the top of the shadow, and pick a semi-transparent black for the color. You can uncheck Raycast Target and Maskable, we don't need them. Next step, the background of our bar. Copy-paste the shadow element and rename it background. Pick an opaque dark gray and reverse the margin, 16 pixels on right and bottom. Everything fits perfectly in the parent container, so we can make it invisible to see the effect. See? It really looks like a drop shadow. I want to push the effect a bit more, so I will increase the background margin slightly. To add a border, copy-paste the background, rename it Frame, change the source image to the frame PNG, and set it to opaque black. Yeah, it starts to look like something, right? Let's add some color with the progress bar. For this, we'll use a mask to hide the sprite based on the fill level. Copy-paste the background, rename it Prefill Mask, remove its image component, and add a rect mask 2D component, and set its Y pivot to 0. Copy-paste the background as a child of the mask, rename it Prefill Bar, and give it a color. Once Maskable is checked, if you change the padding top of your mask, you will see your bar change size. This is the prefill bar, so give it a lighter color. Now just duplicate the prefill mask, rename it Real Fill Mask, rename its child Real Fill Bar, give it a more vibrant color, and we're done with the graphics. Still with me? Let's dive into the scripting. Create a new class to store the data. I call mine Power, but you can call it Health, Mana, or, since the code is generic, Resources to reuse it everywhere. Add the serializable attribute so you can see and edit a variable directly in the inspector, even if the class does not extend Bono behavior. First, add 3 variables: max value, min value, and current progress. Then, a series of events that external script can listen to for change. When it increases, decreases, when a change is rejected, or when the value hits or leaves an extreme. The ratio function returns a number between 0 and 1, representing how close the value is to the maximum. You will use the increment function to increase or decrease power points. If the change is positive but the value is already at max, we check if anyone is listening to the onReject event. If so, we trigger it and stop here. Same logic if the change is negative and we're at min. If the change is negative, we were at max and something is listening to onLeave max, we trigger it. Same for onLeave min, if we were at min and increase. We add the modification to the current value and fire new events. OnFilled if it increased, or OnConsumed if it decreased. Finally, we check if we just hit an extreme and fire the associate event. You probably notice I don't use a minimum in the ratio calculation. To keep it simple, I assume it's always 0. But if you want to change that, just factor it into the math. Moving on to the second script for the display, PowerBar. This one must extend MonoBehavior to be attached as a component to your UI. It exposes some reference variable. Basically, we are linking the part of our UI here. Then, some config variable, prefill color and speed, real fill color and speed. To keep the tutorial simple, I'm instantiating power here, but in your game, you will probably pass it as a reference to an init function. Then, some private variable, max mask 8, and display value for prefill and real fill. In awake, we get the mask usable height and call init. In init, we apply the chosen color to our bars and call refresh. The ratio pre and ratio real function returns the display ratio for each bar. The update function is called every frame by Unity. Again, for the tutorial, I'm detecting some input here. Enter to increment by 10, space for -25. Then, we interpolate the value of each bar based on their display speed to create a smooth animation. We call refresh. In refresh, we just need to update the padding top for each mask. Back in Unity, add this component to your PowerBar, link the references, and tweak the settings. Here is how it looks. Hey, it's looking sharp. But we're not stopping here. Let's add some game feel. For this, I'm using a tool called Fillcraft, link in description. Create an empty object and add the Fill Manager component. Then add the fill component to your PowerBar and check is parent fill since it's at the top of the hierarchy. Go back to your PowerBar class and add an entity ID reference. We'll need it to tell Fillcraft which object to trigger, and a list of tracker state, which I will explain later. In Awake, store the entity ID reference. Make sure to get the one from the game object. Then listen to the Power class event to trigger animation. For example, every time onFill is triggered, this lambda activates. It calls the trigger function of the fill manager with the state name, a power multiplier, the number of loops, and the target entity ID. In this case, we fire and forget. We do the same for onConsumed and onReject. OnReachMax is a bit different because we want the animation to repeat as long as the bar is full. So we set it to loop infinitely and keep the tracker state reference to stop them later. OnReachMin is another fire and forget. Finally, onLeaveMax, we stop the animation we stored earlier. Now for the animation, and again it's going to be super simple. We'll add a shake animation for when the bar fill up. Create a field folder and an animation group. Right-click, create Fillcraft base group. Then an animation layer. For the shake, we want to play with the rect transform position. Right-click, create Fillcraft specialized rect transform position. Pick this curve for the shake, set a short duration, I will go with 0.5, then define your offset. Let's keep it subtle. 10 on X and 5 on Y. In the field component, add a new state, name it field to match the script, and reference your group. Let's boost the effect by having the prefill bar change color at the same time. Add the field component to your prefill bar. Don't check its parent field here. Add a state and name it field again. Create a second animation group. This time, we want to animate the image component color. Right-click, create, Fieldcraft, Specialized, Image, Color. Select this curve. I want this flash of color to be even faster than the shake, so I will set it to 0.25 with a high color offset. Link the layer to the group to the state, and let's see the result. See that little light flash with the prefill? Let's add one to the real field too. Follow the same step for the real field bar, but use a grayer tint for the offset this time. I like it, but the duration was too long. There, 0.2 is perfect. Now, a different feedback style for when the bar drops. I want it to feel more impactful, to mark the negative aspect. Create a consumed folder, a group, a rect transform scale layer. Let's try this value. Link everything to a new state named consumed. Punch it up by adding another layer for the position. I will give you a second to copy my values. You can really feel the impact now, but it's missing that negative loss vibe. Let's animate the real bar color. New group, new image color layer. Fieldcraft applies change additively, even for colors. To find the right value, I will use the color picker to see which channel to modify to reach red. If I decrease the green channel, it turns red. Perfect. Back in the layer, I apply an offset on the green channel. Right now, it increases, so I just flip the curve to make it subtractive. Link it all up to a consume state on the real field bar and let's test. I don't know about you, but I think that's visually very effective. For the next effect, I want to clearly show when the bar is full. I'm thinking a blob style animation. Create a maximized folder, a new group, a rect transform scale layer, and animate it like this, only on the y-axis. Cool, it really conveys the idea to the player. But let's go further by animating the shadow too, for more depth. New group, new rect transform scale layer, add fill to the shadow, create a maximized state and link it all. After some trial and error, I got this result. To make the info even clearer, let's make the bar pulse slowly. New group, image color layer, pick a dark gray for a subtle offset. Add this state to the real fill bar. Alright, now for the reject feedback. We want the background and real fill bar to flash slightly on rejection, so it's visible even if the bar is full or empty. Finally, let's make heading 0 more impactful with a bigger shake. Create your folder, group, and a rect transform position layer. This time, use the randomization option for the offset to add some visual variety. Again, it takes a bit of tweaking to get the feel right, but you will get there quickly. Complete the effect by tinting the background toward black and adding an extra shake to the shadow in all states. And you have your final result. I hope you enjoyed this tutorial. Let me know what you think in the comment or with a thumbs up. If you're interested in the tool I used for the game feel, the link is in description. The code and animation we just made are included. See you next!